Hello and welcome to MLT Tech Talk. My name is Nicole Hutchison, your host for this podcast. I'm joined today by Wilco van Ginkel, MLT's data and analytics lead. Thank you so much for joining me today.
Thank you very much for having me. Pleasure.
I'm excited to sit down with you today, Wilco. This is really the first podcast edition of the MLT Tech Talk, and you're here to talk to me and whoever listens to this podcast about data preparation. So I guess where we have to begin with that is, can you first explain what data preparation is?
I will try. I'll try to do in simple terms, but essentially data preparation in a nutshell is taking raw data and turning that into clean, consistent, uniform data sets. That's it. Well, when you have those uniform data sets, then you can apply the whole machine learning and analytics. Now, that sounds very easy. In reality, it's pretty tough. So what typically happens with data preparation, it goes to a so-called data pipeline. So, for example, let's say raw data. Let's say you have a bunch of Google Sheets with data in it. So first you need to have access to the data. Okay, so you have to acquire the data. And if you go on our website, you will see more information how that acquisition really works, because that can be pretty challenging. When you have that data, you need to normalize it. In other words, it has to be in a format that is consistent and uniform, because you have to talk about columns and rows that has the same meaning. Then you can apply filter operations. For example, I only want to see the date of last year, or I want aggregation. For example, give me the sum of all salaries in this company instead of individual cells. And then you have to deliver that data set. In other words, it has to be available for consumption. So that essentially is data preparation. Again, if you go to our white papers or the blog, you will find more information about it. But that is what data preparation is in a nutshell.
So you kind of already touched on my next question, but I think a deeper dive on it would be kind of cool. So what or why is data preparation so important?
Well, you may have me here talking about the so-called data iceberg. Okay, so the data iceberg in a nutshell, again, is like a lot of people focus on the top of the iceberg, which is visible, which is cool, which is what everybody's reading about, but not a lot of people in the organization focus on the 80%. The truth of the matter is, if you don't have the 80% done, you cannot even start with the 20%. So data preparation is all about getting the 80% done. Okay, and a lot of organizations start to realize that now, but a lot of organizations also have trouble with it. Why is that? Not only from a technology point of view, but also because they underestimate the effort. They go in there and they think the other way around. They think like, 80% is all about the machine learning models, the pipeline, the workflow. It definitely has its work. And then 20% is, we have to get the data ready. No, it's the other way around. And why is that 80-20 and not like 20-80? The reason is that if you see how we have accumulated data in our society over the decades, data is in all kinds of different formats. Okay, so you have the so-called the structured versus unstructured data. So for example, videos, images are unstructured data. Structured data is typical database. So that's already a start. It's in data silos. I mean, everybody has their own data, even in small companies. Everybody has their own data somewhere living. You have data politics, meaning like people are sitting literally on the data and they don't want to give access. You have, of course, the legislation. Okay, like sometimes, like in healthcare, you want to have access to data, but you're not allowed to. And then the final one is that you also need domain expertise. Everybody who thinks like, we walk in, we apply machine learning, and magic happens. That's complete rubbish, okay? It is, I strongly believe, or we strongly believe in a hybrid model where, yes, technology can do work, machine learning can help, but we still need to have humans in the loop, at least for some projects, where domain expertise plays a role. Because sometimes as a data scientist, you may go in a certain direction and you need a sanity check, like, this is complete rubbish because of this and this and this. And we have seen it a few times. Not that we've been called out to be rubbish, but like, we thought it was this and that, and then the domain expertise expert said, no, it's not because of this and this. And because, as MLT, for example, we work for so many different companies, we cannot be an expert in any domain. So we need those domain experts with us during the journey to make sure that what we are modeling and the data, how we look at it, makes sense.
So you spoke about data being kind of all over the place right now, the way we've collected data, the way data kind of exists currently. And I imagine that brings on a whole different, like a plethora of challenges when working to try and create something that spits out actionable insights or anything of the sort. So I guess the question is, what are the big challenges with data preparation?
Yeah. So the big challenges is essentially, one of the biggest one is underestimating the effort. And that's simply because they don't realize the effort that it takes to really get there. The other one is, it's related to one of the other things I said earlier, is working in isolation. So they don't do that due diligence, like, is this really what we need to do? Is the data really there? Is this the right data that we need? So working in isolation. The politics, as I mentioned, people just don't want to give away the data. Legislation, and another one that is important is closed-off proprietary system. So data that lives in closed-off proprietary system. So why is this important? If you look at over the last few decades how we built software before the cloud came in, it was all about proprietary software, enterprise software, one vendor, one solution kind of thing, not being built with an open mind, literally. So there were no APIs, application program interface, to talk to the system. Data was not open data, it was their own format. If you look nowadays how systems are being built, which is more from a decoupled point of view, so we have got modules that run on its own, they communicate with each other using APIs, data is becoming more and more open. That's a whole new concept, and that concept is great because technology-wise it is supported now. But again, the reality is that maybe 80-90% of the systems that you're going to focus on will have, or could be, closed off and proprietary. So the data gems that you need are in a system that is very difficult to access. And again, that circles back to the 80%, that you may have a great idea for a machine learning model, how to apply it to that data. The problem is having access to it. It's like you see a beautiful castle, but you don't have the key to the castle. It's like, it's a beautiful house, I cannot get in.
Yeah. Yeah, I'm stumbling because I'm like, that's really interesting. So you talked about, so you have data kind of all over the place. There's a challenge accessing the data, and there's different components that make kind of preparation of the data more challenging. So what can people do to get in front of these challenges, to whether you have the right data or not? What can people do moving forward to kind of get in front of this?
Well, it is getting better slightly, but it's a kind of a paradox, because part of doing the data explanation is exactly answering this question. So ideally you would say, I've got the right data, I got it right out of the gate, and we can work with it. In reality, again, this is not the case. So yeah, the multi-million-dollar question is essentially like, how would you know upfront whether you have the right data? I mean, that's everybody is looking for, because that reduces the 80% of effort you have to put it in a project, right? And it's a kind of a paradox, because you want that upfront, but you don't know the answer. In order to get the answer, you have to go through the hoops. Okay, so it's very hard to determine upfront. And essentially, a machine learning journey of a machine learning project, I should say, is a journey with really a lot of trial and error. Again, what you read in the newspaper is only maybe the 0.1111% that the Googles and the Facebooks and the Amazons of this world do. Like, and it all sounds like, oh, this is simple. This is we found the holy grail. It's easy. It's not. It's just bloody hard work. And it's a lot of trial and error. And remember, I was talking about the domain expertise. You have to have included. You have to have the stakeholders online. The data is just dirty most of the time. So there's a lot of work involved. Now, that being said, can you improve it a little bit? I think you can. And what we have developed as MLT is what we call a data readiness capability assessment. So essentially, what you do is, it's high level, but it gives you an indication. Is you look at certain data sources. So remember that data preparation is taking raw data, turning it into clean, consistent, uniform data sets. So you're going to look at raw data. For example, you have a bunch of Google Sheets, or you have a database table with transactions, okay? And you're going to ask yourself a few questions with the data owner, like, okay, the data source, is it complete? In other words, is all the data that I'm looking for example, if you have a Google Sheet with orders, are all the orders that I need, are they in the data set, yes or no? This may sound silly, but you will be surprised. Is the data source machine readable? If it's not machine readable, then it's like, okay, I can make an effort to make it machine readable, but the question becomes, is the effort, does it outweigh the benefits? If it is not machine readable, it cannot be used as a data source. Okay, is that a problem? Maybe. If it is an important data source, but I have an alternative, okay, then you may go with the alternative. If there's no alternative and this data source is so important, but the effort is still too much, then you may have to look at a different machine learning model, or maybe you have to look at a completely different way of looking at the problem overall. Another aspect is noise level. Noise level is like how much, it's about integrity of the data. So if you have relational database management systems, I mean, they're all about integrity. So the integrity there is quite okay, but it's also in the semantics. What do we mean by that? If I ask you, write your name, you might write your name as Hutchison.Nicole. I write my name maybe as W.van Ginkel. So it's like the entity is name, but the way how we go by the name is different. So how can a system know that is it last name or surname, then first name, or is it first name, surname? So we have seen many data sets where there is inconsistency in even the same data item. So that's also noise level. So from a syntax point of view, yeah, this should be a name. Yes, it is a name, but the format of the name is not being guaranteed, like as in surname, first name. So you get a lot of those nitty-gritty things that you go through when you do the data preparation. So that's why in this stage it's very difficult to know upfront, unless you're in a very clean, concise, structured data management system. But again, the majority of the companies are not that way. I mean, look at companies, they have Google Sheets, they work in Teams, Microsoft Teams, or in Slack. They have files all over the place on network drives. It's just a bunch of different data, and it's very, very difficult to upfront tell, okay, you have the right data. And that's one of the first things that we do when we do a process. Not only talk about the stakeholders first, but then, okay, let's look at your data, because if the data is like the fuel to the car. Without fuel, the car is not going anywhere. So we need to make sure we have the right fuel, and we have the right amount of fuel before we even can start driving the car.
This has been great. Thank you so much for your time and talking about data preparation.
Pleasure.
And I think many people will find it very insightful. So thank you again, Wilco, today for joining me for a podcast edition of MLT Tech Talk. My name is Nicole Hutchison, and have a great day.